Good morning. My name is Lokesh Sp I am from first year CSEB, and today my topic is lasers and their characteristics. So before we discuss about lasers and the characteristics, let us first of all know what is a laser. Laser is a light amplification stimulated emission of a radiation. So coming to the introduction of the laser, laser is a device used to produce a powerful monochromatic narrow beam of light in which the waves are convergent, which means the waves in the laser are convergent and they produce a narrow beam of light. Laser is an acronym of light amplification by stimulated emission of radiation, and whereas maser is the acronym of microwave amplification by stimulated emission, which means the terms laser is acronym of light amplification and maser is an acronym of microwave amplification. The light emanated from the conventional light source like candle, sodium lamp is said to be incoherent because the radiation emitted from different atoms do not have a phase relationship between them, which means if there is no phase relationship, it is incoherent. If there is a phase relationship between the atoms, it is coherent. Lasers are much important because the light sources have high monochromaticity, high directionality, high intensity, and high coherence. These are the characteristics of the lasers. In the laser, the principle of maser is employed in the frequency range between 10 to the power 14 Hertz and 10 to the power 15 Hertz. And it is termed as optical measure, which means the maser is the optical measure, which has a frequency 10 to the power 14 Hertz to 10 to the power 15 Hertz. Laser principle is nowadays extended into gamma rays. So it is called, the gamma ray lasers are called grazers. The first two successful lasers developed are ruby laser and the helium neon lasers. These lasers were developed in 1960. These are the first lasers to be developed. Some lasers emit light in the form of pulses, while other as a continuous wave, which means the lasers can be emitted in two forms, that is the pulses and the continuous wave. So coming to the characteristics, there are mainly four characteristics of lasers. The first one is highly monochromatic, and the second one is highly directional, and the third one is highly coherent, and the fourth one is high intensity, which means the laser is having high intensity, highly monochromatic, highly directional, highly coherent, and high intensity. Now coming to each of them, highly monochromatic. The bandwidth for a normal light is about 1000 Armstrong, which means that normal light is a bandwidth of 1000 Armstrong, and the laser has a bandwidth about 10 Armstrong. The narrow bandwidth of the laser light is called high monochromaticity. Laser light is more monochromatic than the conventional light source, which means the light source from the laser is highly monochromatic compared to the light source from the normal conventional source like sodium lamp or candle, etc. Because of this monochromaticity, large energy can be concentrated in a small bandwidth. Because of this high monochromaticity, large energy can be concentrated in a small bandwidth. For a good laser, the value of dV is equal to 50 Hertz and V is equal to 5 into 10 power 14 Hertz, which means this is the degree of non-monochromaticity for a conventional sodium light. So winding up the topic, highly monochromaticity means laser large energy can be concentrated into a small bandwidth, and the bandwidth of ordinary light is concentrated in a normal light. Now coming to the highly directionality. The conventional light sources like lamp, torchlight, candle, sodium lamp emit light in different directions. This property is called divergence. Lasers, in the other hand, emit light only in single direction. This is called directionality of laser light, which means the light is emitted by the laser in only single direction. This is called the directionality of the laser light. And coming to light from the ordinary light spreads about few kilometers, up to some kilometers. Light from the laser spread to a diameter less than 1 centimeter for many kilometers compared to that of conventional light sources like candle, lamp, etc. The directionality of the laser is expressed in the form of divergence. The divergence theta is equal to R2 minus R1 by D2 minus D1. There is a theta difference between angle difference. Theta means the angle. The directionality is expressed in the term of divergence, and that is in the form of theta difference is equal to angle difference is equal to R2 minus R1 minus D2 by D1. Here R2, R1 and D2, D1 are the differences of the distances. Hence, for getting high directionality, there should be a low divergence, which means if the divergence is low, directionality is high. If the divergence is high, directionality is low. Both of them are inversely proportional to each other. This is about the highly directionality of the laser light, which means the light travels only in single direction. This property is called highly directionality. And coming to highly coherent. When two light rays are having same phase difference, they are said to be coherent. if their phase difference is different, they are not coherent, which is incoherent. It is expressed in the form of ordering of light field. Laser has high degree of ordering than any other common sources or conventional sources like any normal ordinary light. Due to its coherence, only it's possible to create a high power, about 10 to the power 12 watts in space with laser beam of 1 meter diameter. These are the two independent concepts. There are two independent concepts of coherence. Before we discuss about them, let us now find out the topic. Laser has a high degree of ordering than any other common sources, which means if the phase difference is same, then the light sources, laser light sources are said to be coherent. If it is not same, they are not coherent. And there are two independent concepts of coherence. The first one is spatial coherence and the second one is temporal coherence. We will be discussing about them now. Spatial coherence. The two different light fields at different points in space maintain a constant phase difference at any time. It is said to be phase difference, which means the two light fields at two different points maintain a constant phase difference. Then it is said to be spatial coherence. So, for the light spatial coherence to be possible, there should be a constant phase difference. There should be constant, which means that space difference should not be changing. It should be constant. And let us take an example of helium neon gas layer. In the helium neon gas layer, the coherence length is about 300 kilometers. It means the phase difference is maintained over any time. It is constant over any time. For sodium light, it is about 3 centimeter. The coherence and monochromaticity are related by the following formula. Delta V by V is inversely proportional to 1 by LC. For the high coherence length, is small, hence it is high monochromaticity, which means, as we said earlier, monochromaticity and coherence are directly related to each other. Which means if the monochromaticity increases, the coherence length also increases. If the monochromaticity decreases, coherence length also decreases. This is about spatial coherence, which means a constant phase difference should be maintained across the two light fields. Now coming to temporal coherence. Temporal coherence is the correlation of phase difference between light fields at a point over a period of time. For helium neon laser, it's about 10 power minus 3, and for the sodium, it's about 10 power minus 10 only, which means the temporal coherence of the sodium is less for sodium, which is 10 power minus 10, whereas it is higher for the helium neon compared to the sodium, that is 10 power minus 3 seconds. It is denoted by the following formula. And the temporal coherence and the monochromaticity are directly proportional to each other, which means higher is the temporal coherence, higher is the monochromaticity. Higher is the monochromaticity, higher is the temporal coherence, which means if one of them increases, the other also increases. If one of them decreases, the other also decreases. And coming to the high intensity. Intensity of a wave is energy per unit time flowing through a unit area. This is the basic definition of intensity. The light from an ordinary source spread uniformly in all directions and from spherical wavefronts around it, which means the light from an ordinary source is spread uniformly spreaded in all the directions. For example, if you look at it 100 volts bulb from a distance of 30 centimeter, the power entering the eye is 1 by 1000 of the watt, which means the power is reduced by the time it enters our eye. But in the case of laser light, the energy is in small region of space and small wavelength is said to be of greater intensity. The power range of laser is about 10 power minus 3 watt for gas laser and 10 power 9 watt for solid state laser. The number of photons coming out from the laser per second is given by the following formula, which means the intensity is nothing but the energy per unit time flowing through unit area. The light from ordinary source spread uniformly, but in the case of laser light, the energy is in small region of space and in a small wavelength and is said to be of greater intensity. Small region of space, greater intensity. Larger space, less intensity, which means both of them are not related to, inversely related to each other. This is about characteristics of lasers. Okay. Till now we have discussed the characteristics of the lasers and what is the acronym of the laser. And now we are going to discuss the merits and the demerits of the laser. Now coming to the merits of the laser, lasers have a high information carrying capacity and hence they are used in the domain for the communication, transformation of information. It means it is used in the field of communication. And lasers are free from the electromagnetic interference, which means there is no electromagnetic interference in lasers. This phenomenon is used in optical wireless communication for telecommunication as well as computer networking, which means lasers are used both for computer networking as well as telecommunication, which means lasers are important in the field of communication. And there is very minimum level of signal leakage in lasers. Laser based fiber opticals are very light in weight and hence are used in fiber optical communication system. Fiber optical communication requires the fibers which are of very less weight and easy to maintain. So lasers are used in the field of fiber optical communication. And compared to the X-rays, the laser light source is very less damaging, and hence it is widely used in the medical field for the treatment of cancers. It is used to burn the tumors on the eye surface and also on the tissue surface and the dead skin cells. So lasers are also used in the medical field widely, as well as the communication systems like optical fiber communication and computing networking. Now coming to the, as we had discussed earlier, that lasers have high intensity and low divergence. This feature of high intensity and low divergence is used for knocking down the enemy tank with accurate range determination, which means the lasers are also used in the field of defense. For this purpose, neodymium and carbon dioxide laser types are used. Neodymium and carbon dioxide are two types of lasers which are used in the field of defense. Laser rangefinder is also used in several defense areas for medium range up to 10 kilometers. There is a laser rangefinder which is also used in some defense areas which has a range up to 10 kilometers, but after the range of 10 kilometers, it cannot work. This property of lasers using in the field of defense requires lasers high intensity and low divergence, which means if it's laser having high intensity has low divergence, high intensity. And coming to the next point, a single laser beam can be focused in areas smaller than 1 micro diameter, which means it occupies very less space, and 1 square diameter is used to store 1 bit of data. So this helps in storing 100 million data in 1 square centimeter, which is very useful in storing the data in the form of CDs, DVDs and documents. Due to this fact, lasers is used in CDs. The principle of lasers is used in CDs, DVDs for data storage in the form of audio, video and document. So winding up the topic, the main merits of the lasers are it is used for transmission of information and also in the field of computer networking and telecommunication because there is very low level of signal leakage, and due to its lightweight is also used in optical fiber communication, and due to its less damaging feature, it is also used in the field of medical, used to treat the tumors and the cancers and all the dead skins on the skin. I mean, it's also used in the medical field. And due to its property of high intensity and low divergence, it is also used in defense field with the help of a rangefinder up to 10 kilometers distance, used to attack the enemy with a determined range. And the single laser beam can be used, that laser can be used to store data in very less area. So 100 million data can be stored in 1 square centimeter. So lasers are also used in making CDs, DVDs for storing audio, video, documents, other type of data documents. So this is all about the merits of the lasers, which can be useful to, which are useful to us. And coming to the demerits, the main demerits of the laser is it is very expensive and is not affordable by many of us. So the first point is it is expensive and hence more expenditure to the patients it's required. Means the patient has to spend a lot of money for acquiring the laser based treatment, and it is costly to maintain and hence more cost to doctor and hospital management. The maintenance cost of the laser beam is also costly and increases complexity. There is a high level of increasing complexity and duration of the treatment compared to the normal treatment. But the laser based devices requires high complexity and duration of the treatment is also more. And the main point is lasers cannot be used in many commonly preferred dental procedures. Means lasers cannot be used in every method of treatment. Means, for example, a dentist need to fill cavities between 2 teeth. Then laser based treatment cannot be used. And even if it's used, it takes long time. And next, laser beam is very delicate to handle in cutting process. Lasers are also used to cut the metals. As I mentioned earlier, also used in medical field, optical fiber is also used to cut the metals with strong laser beam. Laser beam is very delicate to handle in the cutting process. The slight mistake in adjusting distance and temperature may lead to burning or discoloring of the metal, which means even if there is a slight mistake, the total process may go wrong, lead to burning or discoloring of the metals. Moreover, it requires high power during the cutting process. Low energy supply is not preferable. It requires high energy and high power supply during the cutting process. And main thing is laser is harmful to human beings and often burns them during the contacts. If laser touches the human surface, it's very harmful and leads to burning. So main thing of the main demerits of the laser beam is it is expensive. It is expensive and hard to afford and hard to maintain, and the duration of the treatment is very hard, and it is not commonly preferred in every medium of treatment, and it is very delicate to handle and requires high energy supply and power supply, and it is harmful to the human beings and often burns them during the contacts. And overburning and adjusting slight mistakes can lead to burning or discoloring of the metals during the cutting process of the metal. And there may be a slight data leakage during this using this laser beam. Thank you.